Hello, good afternoon, boys and girls. How are you? I hope and trust you guys are doing good like I'm doing good here. This is your man or your teacher, Franco, coming live to you with fundamental accounting principle. We're still continuing this week. We have a question on the board. We're going to look at it and look at many questions as usual. How many numbers greater than 23,000 can be formed from digits 1, 2, 3, 5, and 6 without repeating any digit? So the underlying word is without repeating any digit. We are forming numbers that are greater than 23,000 from digits 1, 2, 3, 5, and 6 without repeating any digit. So, boys and girls, when such question is given to you, we need to know how to go about it. We need to know how to go about it and solve the question without going through any hassle. So now let's see. Now we are forming numbers. So this 23,000 has got 5 digits in it. 1, 2, 3, 4, 5, for instance. Now we are saying that the numbers that can be formed must be greater than 23,000. So which means that out of these digits that were given 1, 2, 3, 5, and 6, number 1 cannot fill the first position because it's less than this 2, which is the thousands in 23,000. So you can see that number 1 cannot fill the first position, so it's out of the digits. So we'll be remaining with numbers such as 2, 3, 5, 6. This is where we can choose from to fill. And of course it must start with 2. So if it's going to start with 2, the number must start with 2. It means the first position here can only be occupied by the number 2. The first position here can only be occupied by the number 2, and that you can write it as 1. Okay? Because you have chosen 2 out of the many numbers to representing the first position. The first position can only be represented by the number 2, and that is one number. So here you put 1 there. Okay? This 1 here does not mean the 1 in the digits. It means that the number 2 has been chosen out of these 4 remaining numbers to fill position number 1. So you write it as 1. Okay? Now when you choose 2 to represent here, the question says any digit that is chosen must not be repeated. I hope you understand that. Now I'm going to look at what number can occupy position number 2. So on position number 2, let's check the numbers that can occupy. We still have digits from 1, 2, 2, 3, 4. We have digits 1, 2, 3, 5, and 6 to choose from, guys. So we said only number 2 can represent position number 1. But as we are looking at 23,000, we are looking for numbers that are bigger or greater than 23,000. So this 3 here, we are looking for a number. That means 1 cannot also be used again. We can't use 1 in position number 2. Why? Because 1 is less than 2 and is less than 3. We can't use it here. So, but because we have already used 2 to occupy position number 1, the question says it must not be repeated again. Alright? So since 2 has been used, it means we'll be left with how many options to choose from? Now since 2 has been used, we can now have numbers such as 3, 5, and 6, because 1 and 2 can no longer be used to occupy this position. So this position can be occupied in 3 ways. Either 3, 5, or 6 can occupy here. So we have 3 ways here. Okay? Now the next thing is, we are moving from, this is 23,000. So we are looking for numbers that can occupy here. So this can be in numbers that can occupy position number 3. Now, since we have used 2 here and the digit 3 here, it means that we now have to check what number can we use for these 3 zeros that are there. But you can see simply that now in position number 3, 3 has already been used and it cannot be used again. But then in position number 3, we can now bring in 1 again, because 1 can be used, because here, if you have 23,000, say 100 is greater than 23,000. So 1 can be used, and then we can have 5 and 6 again in position number 3. Here, 1 can be used here. So here you have also 3 options to choose from. So here will be 3. I hope you understand what I'm doing. And then let's come to this position here. Now, if you have 3 options and you choose 1, then it means you'll be left with 2 options here. And if you have 2 options and then you choose 1, it will be left with 1 option. So your answer here will be 1 times 3 times 3 times 2. And that is going to give you 1 times 3 is 3, 3, 3, 9 times 2 is 18. So you'll be having 18 numbers that can be formed from digits 1 to 2, 3, 5, and 6 without repeating any digit. So that will be your answer. Alright. Thank you. If you have any question, you can comment on the comment section. And if you don't have a question, you can also like it and share it as usual. Otherwise, it's simple. So if you got 23,000, you want numbers that are greater than 23,000, first position can only be occupied by 2. So if there's 1, 2, 3, 5, 6, 1 cannot occupy here. So when it can only be occupied by 2, here you write 1 there, because one of the digits occupy the first position. Now, if 2 comes to occupy here, it stands for 1 digit that has been occupying this position. Now, this position here, you ask yourself, what is the next number in 23,000? It's 3. That means 2 cannot be used again, according to the question, without repetition. 2 cannot be used here again. So it is out of the digits. There were 5. And 1 can also not be used because 1 is less than that 3. So we have 1 and 2 out of the digits. We will be left with the digit 3, 5, 6. So it means you have 3 options to choose your number from. 3, 5, and 6. Each of them can be here. Now when you are done there, you ask yourself, what can occupy this position now? Because you have moved from 23. Now you're going to the other numbers. So now you ask yourself, okay, can 1 be used here? Yes, 1 can be used here, because if I have 23 and I put 1 here, it becomes 23,100, which is greater than 23. So 1 can now be used. If I'm going to bring back 1 now, I'll be left with numbers such as 1, 5, 6, because remember, any number that has been used cannot be repeated. So I have 1, 5, and 6. How many options are there to choose from? There are also 3, so you have to put 3 options here. Okay. Now, when I'm left with 3 options and I put it here, it means if I cannot repeat, then it means I'll be left with 2 options. If I cannot repeat it, then it means I can left with 1 option. So when you multiply this, it gives you 18. And that is how we do fundamental counting principle, if those are not repeating. Okay. Now let's take another question here and see how best we can do with our question. Now we're taking another question. Let's quickly look at this question. The question says 4-digit code. 4-digit code Sorry guys. The question is saying that 4-digit code, in bracket you said not beginning with 0, comma, to be constructed from the set of digits, and they will give you the digits. The digits are 1, 2, 3, 4, 5, 6, 7, 8, and 0 lastly. Question 1.1. How many 4-digit codes can be constructed if repetition of digits is allowed. Now you must understand they said the repetition of digits is allowed. Repetition of digits is allowed. So now, boys and girls, if repetition of digits is allowed, then let's see how many ways we can get our 4-digit code. Remember, how many numbers are here in terms of digits, from including 0? 1, 2, 3, 4, 5, 6, 7, 8. Including 0 will give us how many digits? So when I have 1, 2, 3, 4, 5, 6, 7, 8, and 0, this will give me 9 digits in general. So we are considering 9 digits. But they told you the question said repetition of digits is allowed. Repetition of digits is allowed. And I'm making only 4-digit code. So let me create my table here. I want 4 digits. So it's 1, it's 2, it's 3, and 4. I'm going to create my how many codes can be constructed from here. So now, repetition of digits is allowed, but look into this bracket. The question says not beginning with 0. So it means none of the codes you are forming must begin with 0. So 0 cannot occupy this first position. So if I close 0 here now, how many numbers are left? 1, 2, 3, 4, 5, 6, 7, 8. So it means here you have 8 choices to choose from. Okay, in the first position. A code that you form must not begin with 0, so it means 0 is out, and you are left with 8 digits to choose from in the first position. Now, they did not tell you 0 cannot work in the second position out of the 4 codes you are choosing. So it means that immediately after this position, I can bring my 0 back. And that means in this position, I will have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 digits will be here. They said it can be repeated again. So here will be 9 again. I can also choose from among these 9 again. So this is going to be your solution at the end of the day. So this is going to be 8 times 9 to the power 3, or times 9 times 9 times 9. And your answer is going to give you, when you put it on the calculator, it's going to give you 5832 codes. So the number of codes that can be made if repetition of digits is allowed will be 5,832 codes. I hope you have understood it. First position, 0 is not allowed. So if 0 is excluded, you count 8 digits and you put it here. At the second position, they didn't specify that 0 is not allowed. That means you can bring 0 back to the digits. And then when you count them, it is 9. A number can be repeated. A digit can be repeated. So it means that if I take 1, I can repeat it 9 times to form my code. So if I put 9 here, here was also going to be 9 because repetition is allowed. And here is also going to be 9 digits that I'm going to choose from. So when you finish, you multiply. Don't leave your answer like this. You take 8 times this box, times that box, times that box, and then write your answer and press your calculator. So that's this. Take note, I'll come back. We will look at this question again where repetition is not allowed. Let's say in this same question, how many 4-digit codes can be made or constructed if repetition of digits is not allowed? Of digits is not allowed. Let's look at this question again. If repetition of digits is not allowed, we have seen where repetition of digits is allowed. The same question, 4-digit code not beginning with 0. So in this case, still, the first position cannot begin with 0. That means out of 9 digits, 0 is exclusive. Then you'll be left with 8 digits. So the first position can have all these numbers. You can choose any of them to represent here, and there are 8 of them. So you put it here in the first position. Now, coming to the second position, they are saying the